Welcome to a new video of RoboCNC. I'm Marcel. This is the second video of the RoboCNC router build, the X2 router build. And today we try to finish up the Z-axis. Let's go to the workshop. So welcome back in the workshop. This is the front plate of the Z-axis, so the moving part. And of course with this beautiful logo in it. When we look at the back side, you see I machined two grooves into the back plate, and these grooves will be used to align the Hewin rail, the 15mm Hewin rail. So the arrows point to the aligning side, so turn it like this and slide it against the groove. This way I'm really sure it's perfectly square to the plate. In the comments on the previous video somebody asked if I machined these aluminum parts myself, and indeed I did. It's aluminum 60, what was it again, 6082, which is a European equivalent of 6061 T6. Which is more commonly known in the US. So both 15mm Hewin rails are mounted to the plate. Now it's time for the bearing blocks. I went with the HGW15C, which is the flange type, so the bearing blocks with a flange, which is important for mounting these, so make sure you follow along. Again, it has a shiny side and a back side on the bearing, and the shiny side is going to be on the reference side of everything, so on the reference side of the rail in this case, like so. And you can also see it on the text on the back. Make sure the plastic stays inside of the Hewin carriage to prevent the balls from falling out. And put it onto the rail with slight pressure on the plastic piece to keep it in place. So while I'm mounting these Hewin carriages, I can tell you one of the stupid mistakes I did. I bought these Hewin rails and the carriages from Damen CNC. Link is provided in the Excel sheet. And they shipped the Hewin rail with some green caps, and these green caps are to fill in the holes above the screw caps, or the socket head screws. And this is to prevent dust and stuff from getting into the carriages. So it's really a smart thing to use these green caps, but even smarter is to place them right now, because I forgot and I had to do it while the complete Z-axis was all together, and I can tell you that's not a fun job to do. So don't do as I did, place the green caps now. So these are the spacers I will use on top of the Hewin carriages, and in them you see these two spring type straight pins, heavy duty straight pins, and these are used to align the moving part of the Z-axis with the stationary part, and these are the heavy duty version from February. So the part number, they will be mounted like this on top of the Hewin carriages. So the straight pins make sure the spacer blocks are aligned with the stationary part of the Z-axis, but how do we align the spacer with the moving part of the Z-axis or the carriages of the Hewin rail? Well, as you can see, these bolts, they are a really tight fit. I have to push them inside of the pockets. So basically, if the bolt pattern in the Hewin carriage is straight or exactly square and the bolts are exactly cylindrical, we're fine. And off camera I checked this by setting the dial indicator on the other rail and moved this spacer block around to see that it was working perfectly. And it is. So this is a great way to get the spacer exactly in line with the Hewin carriages and the Hewin rail, and therefore with the front plate of the Z-axis. Now we can focus again on the stationary part of the Z-axis. First of all, we're going to place this bearing. It's the BK12 series bearing. I found it on eBay. It's really cheap, and it has two angular contact bearings inside of it. So it can be used to as a fixed bearing for a 12mm bore. So next up is the M16 Ball Screw, 60mm diameter, 5mm pitch. It's also from eBay, from our friend Chai. It's a Chinese ball screw, but really I've worked with this ball screw now for a couple of years, and I think the quality is good enough to use. Make sure when you order it to get 2 of these lug nuts. They are M12 with a 1mm pitch, if I recall correctly, but make sure you get 2 of them. Well, these lug nuts have some sort of ring on one side of them. Place these towards the bearing, the BK12 bearing, and tighten the nut. On the corners of these lug nuts are small Allen keys or Allen screws, set screws. They can be used to lock the nut in place, but the thread on the ball screw can be damaged by using these. So that's why I want to use a second lug nut. So this one is placed with the ring towards the top to get a better grip. You can also see the brackets I made for the ball nut. The first one on the ball nut side is fixed to the ball nut, and the second one is still floating. Well, you'll see why later in this video. So now the time has come for the stationary part and the moving part of the Z-axis to come together. But the only way to do this is by taking off the stationary part or taking it off the bridge or the Y-axis. So I turn it around to have a better view on the carriages, because if I just take it off, all the balls will fall out of the Hewin carriages. So that's why we kept these plastic parts. So with care, place these plastic parts back into the carriages and give light pressure on them and slide the z-axis of the y-axis. Really be careful, because if you lose the balls in these carriages, well, you're probably what's the best word now? And that's a win. So put the stationary part on top of the moving part, and you see there's quite a gap. This gap is from the pins, the straight pins, so it's exactly the stick out of the straight pins. So using 8 bolts, this needs to be tightened together. But since we need to keep the alignment and the straight pins need to be pushed into the back plate, use a crosswise pattern. Just small amounts of pressure and then on to the next one, and keep using a crosswise pattern to get it closer and closer. Just be patient and go for it. I think you can also imagine that if I ever want to get this back plate off of these spacers, that would be quite hard. Gladly I thought about that in front of time. So if you look between these M6 bolts, you see 4 M8 holes, threaded holes. So basically these are for pushing off the spacer blocks if needed ever. So I can put some M8 bolts in these 4 holes and try to push the bearing blocks or the spacer blocks off this plate. So that's why you see these holes. So it's all together. The gap is gone and it's starting to look like a Z-axis. How do you like this? Nice compact Z-axis. There are 4 temporary bolts in the front plate. It's just to make sure I don't slide off the front plate and lose the ball bearings out of the carriages. On the bottom we have 2 threaded holes. Not sure what I'm gonna do with this, but they're just auxiliary threaded holes. Well, the last thing to do before putting it back on the y-axis, or the gantry, the bridge, is to put in the grease nipples. Still not sure what kind of grease I'm going to use, but we'll talk about that in a later video. So take note of the text on the Hewin rail and the arrows pointing upwards. So this way you know you put on the Z-axis the right way. Again, we're gonna slide it on the Hewin rails and put some slide pressure on the plastic pieces to align it and to retain all the ball bearings. And that's it, it's back on again. So next up is the stepper motor and the coupler. The stepper motor is a Nema 34 4 Nm stepper motor from stappermotor.nl. And the couplers are the same as I used in my last machine, the Optimum BF20. And I really like these, so I'm gonna use them again. They are from RoboCNC. It's the DCNC D32 L32. And I need the 12mm and the 10mm right now, plus the red spider. Although the red spider does really look pink or purple, more than red, but I really like these couplers, and as you can probably see and hear, it's a really tight fit. And they do have some flex in it, but it's a really tight tolerance. And I think you can see that this is a zero backlash coupler this way. Really like them. Well, the 10mm side is put onto the RM1605 ball screw, and I just put it down on top of the lug nuts. Just an extra security measure to prevent the lug nuts from getting loose. There's no flat spot on the ball screw, it's just a clamp fit. So this screw is on the side of the coupler. So this is the top plate of the Z-axis. And it's bolted with 3 bolts to the stationary back plate. Look, my finger now is hiding the cosmetic problem of a broken end mill while machining this. It's very clever. Well, the top plate will house the Nema 34 stepper motor, and it has a beautiful recess in it for this motor, and of course the 4 bolts. And it will house the sensor, an inductive sensor, which I will mount later on. So not in the mood to do the voiceover again, but now I see it's a RoboCNC stepper motor. Still it's a Nema 34 and 4 Nm, that's the same, although this will have a shaft of 14mm and not the 12mm I was talking about. But well, you will just have to match up your stepper motor with the coupler, that's easy enough. So this is the basic design of the Z-axis. It's mostly done. Still need to connect the brackets, the ball nut brackets, to the moving part, but of course I want to show the sliding action and I want to play with it for a while. Still need to do the wiring of the stepper motor and place the sensor, but that will be in an upcoming video. In the next video we're gonna start with the Y-axis, or we're gonna finish the Y-axis. And hope you like this design, hope you like the Z-axis. If you have any questions or comments, please leave them in the comment section below. Hit the thumbs up button, and if you're not yet subscribed, hit the subscribe button. Thanks for watching.